everyone, welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about solving equations with rational numbers. Let's jump right in. Want to take a minute to do a quick review of some of our words that we've been using lately. Let's talk about rational numbers. Okay, rational numbers are any number that can be written in a fraction form. So for example, 3, the whole number 3 is actually a rational number because it can be written as 3 over 1. 1/2 is also a rational number because it is in fraction form. The other thing I wanted to talk about was integers. Integers are all whole numbers, positives, all are positive numbers, and their opposites are all the negative numbers, and of course, 0. Also included is terminating decimals. Terminating decimals, an example of that would be 0.1. And 0.1 is a rational number because it can be written in fraction form as 1 over 10. And also repeating decimals, they are also included in rational numbers. Now when I say repeating decimals, you see this line over the 3. That means that 3 goes on and on and on and on forever. 0.33333. That's also a rational number. Okay. Quickly, let's take a look at equations involving decimals. So the question is asking us to solve for x. 3x minus 2.5x plus 0.5 equals 4.5. Now we need to isolate our variable x, and we do that by following the steps in the order of operations. We're going to isolate our variable, and we'll just kind of take it step by step. All right, first of all, I'm going to rewrite the problem, which I encourage you to do when you're given a problem, write it yourself. 3x minus 2.5x plus 0.5 equals 4.5. Okay, the first thing I did here is I combined like terms. 3x minus 2.5x is 0.5x, and I brought down my 0.5, and I brought down my 4.5. Next thing I'm going to do is I want to isolate that variable, so I need to subtract 0.5 from both sides of the equal sign. I'm left with 0.5x equals 4.0. I'm going to divide both sides by 0.5 because division is the inverse operation of multiplication. And I am left with x equals 4 divided by 0.5, and the answer is 8. All right, next one. Let's take a look at multi-step equations involving fractions. The question says, solve for r. 2/3 r plus 3 over 5 equals 2. So the first thing we're going to do is the distributive property. Okay, so we're going to do 2/3 times r, which I've done here, and 2/3 times 3 over 5, which I've done there, equals 2. Bring that down. Okay. The next thing I'm going to do is solve within the parentheses. So 2 over 3 times 3 over 5 is 6 over 15. Okay. Rewrite all the steps, rewrite all my terms, 2 over 3r, 2/3 r plus 6 over 15 equals 2. Next thing, to isolate the variable, we're going to subtract 6 over 15 from both sides of the equal sign, and I'm left with 2 over 3r equals 2 over 1 minus 6 over 15. Now I want to call your attention to what I've done here. This question asks me to solve what is 2 over 1 minus 6 over 15. I cannot do that until I have a common denominator. So I moved the problem over here to the side to show you how I got my common denominator. So the original problem was 2 over 1 minus 6 over 15. So 15 will work just fine as my denominator, but for my 2 over 1, I'm going to have to multiply the 1 by 15 so that I can have the denominator of 15, and 2 times 15 to get 30. So both of these were multiplied by 15 to get to 30 over 15. And now I can subtract 30 over 15. I can subtract 6 over 15 and come up with the answer of 24 over 15. Which I've plugged back in over here in teal. So that just wanted to show you how I got the common denominator of 15 on that one. All right, moving on. 2 over 3r equals 24 over 15. Now what I need to do is I need to isolate that r, so I'm going to multiply both sides of the equation by 3 over 2. I'm going to multiply by the reciprocal of 2/3. Then I will cancel out. 2/3 and 3 over 2 cancels out, and I'm left with r. My variables isolated. R equals 72 over 30, and simplified, that's 2 and 12 over 30. Simplified even further, that comes down to 2 and 2/5. Sometimes we'll have, here's another one I wanted to talk about, sometimes we'll have problems that mix up multiple forms of rational numbers. Excuse me. In this particular equation, in this particular problem, we have a mix of decimals and fractions. Let's take a look. We have 0.4k plus 0.2k plus 3 over 10 equals 9/10. So the first thing I'm going to do is rewrite the problem as I did here. And I can combine quickly like terms. 0.4k plus 0.2k is 0.6k. Bring my 3/10 down. I'm going to just kind of rewrite the rest of the problem. 0.6k plus 3 over 10 equals 9 over 10. I'm going to subtract both sides of the equation by 3/10. This cancels out to nothing. Now I bring this 0.6k down. 9 over 10 minus 3 over 10 equals 6/10. So now it's written as 0.6k equals 6 over 10. Now I want to change, I've got a decimal, 0.6k. I can pretty easily change that decimal into a fraction. 0.6k is the same thing as 6/10k. So now I have 6/10k equals 6/10. It's getting easier and easier. These cancel out. We're going to multiply both sides by 10 over 6 because we want to multiply by the reciprocal on both sides. And I come up with k equals 1. And I've kind of shown you here how this canceled out as well. Because I'm left with 6 over 10 times 10 over 6, which gives me 60 over 60. And 60 over 60 equals 1. All right, the last problem I want to look at is a quick real-world problem with multi-step equations. All right, here we go. On Sunday, Leah walked 4 miles. On Monday, Leah walked 1/3 as many miles as she walked on Tuesday. I'm going to highlight that. So on Sunday, she walked 4 miles. On Monday, she walked 1/3 as many miles as she walked on Tuesday. She walked a total of 12 miles in those 3 days. Let A represent the number of miles Leah walked. Highlight that A. Let A represent the number of miles Leah walked on Tuesday. So we've got 3 jobs. 1, write an algebraic equation to represent the total number of miles she walked in all 3 days. 2, find the number of miles Leah walked on Tuesday. And 3, find the number of miles Leah walked on Monday. I always encourage my students to write what you know first. And so that's what I've done for you here. What we know is that, and this says these bits of information for us within the problem, that on Sunday, she walked 4 miles. On Monday, she walked 1/3 times, or 1/3 as many miles as she walked on Tuesday. And we're going to let Tuesday be represented by the variable t. So we would just multiply 1/3 times t to identify how many miles she walked on Monday. And in total, she walked 12 miles. Now we need to write an equation. And to write the equation, all we need to do is add up all the days and find the total. Actually, we have the total. The total is 12. We're going to solve for t because once we solve for t, we know how many miles she walked on Tuesday. We'll be able to figure out the rest of the questions, the rest of the answers. Okay, so now I've just plugged in the miles from Sunday, Monday, Tuesday, all added together equals the total. Sunday was 4 plus Monday, 1/3 t, plus Tuesday, t. And the total is 12. I rewrote t as 3 over 3t to make the problem simpler because 3 over t is the same thing as 1. So it's like 1t. But it makes it easier to add 1/3 t plus t. Now I can have it as 4 over 3t. All right? The rest of the numbers I just brought down 2 lines. Now I have 4 plus 4 over 3t equals 12. So have you thought about what my next step might be? Remember, I'm always saying we've got to isolate our variable and we've got to use inverse operations to get there. So we're going to subtract both sides by 4. Now I have this just comes straight down. 4 over 3t. 12 minus 4 equals 8. Highlighter. So now we have 4 over 3t equals 8. Okay, to isolate t, I'm going to have to divide both sides by 4 over 3. To isolate the variable, division is the inverse operation of multiplication. Okay, now what happens is my 3/4 cancels out, 4/3 t, I'm left with t. I have isolated my variable, and I get, on the other side, when I multiply 8 over 1 times 3 over 4, I get the answer of 24 over 4. And simplified, that would be 6. So on Tuesday, Leah walked 6 miles. All right, guys, that just about wraps it up for today. Thanks so much for joining us, and we'll see you next time. Bye-bye.